What if you're asked to simplify this without the use of a calculator? How are you going to do it? You know, it will be really stressful if you have to do 16 times 16 times. Oh, no. It's going to be really, really stressful. So let me show you how you can do this easily without the use of a calculator. Are you ready? Let's get right on it. So look at this. This is 16. This is 16. I'm going to reduce the basis to 2. So I'm going to express 16 as a power of 2. And I will write 2 raised to the power of 4. Then multiply by what? The exponent of 5 minus the same thing here, 2 raised to the power of 4. Multiply by what? By 4. So what is 4 times 5? That's 20. So I'm going to write 2 raised to the power of 20. For one of the laws of indices, if you have a raised to the power m bracket n, you can multiply the exponent to give you what? A raised to the power mn. So that's exactly what I did here. I multiplied 4 and 5. That's how I got 20. So we'll do the same thing again to this one. Multiply 4 and 4. You are going to get what? 16. So I have 2 raised to the power 20 minus 2 raised to the power of 16. Still the same thing. Even if you have to do 2 raised to the power 20, it's still going to be difficult. So what do? Now, because I have 2 raised to the power 16 here, and I'm looking forward to factorizing 2 raised to the power 16, I will express 2 raised to the power 20 like this. 2 raised to the power 20. Sorry, I'll break 20 to the sum of two numbers. That will be what? 16 plus 4. The reason why I chose 16 is because it's a power here too. So minus 2 raised to the power what? 16. From one of the laws of indices again, you know, if you have a raised to the power m times a raised to the power n, this is the product rule. You have a raised to the power m plus n. So that's what I will do here. I'm going to rewrite this as what? 2 raised to the power 16 times, see, from this place here now, times what? 2 raised to the power 4. If you apply the product rule here, it will give you back what? This. So then minus 2 raised to the power 16. The good thing here is that we now have a common factor of 2 raised to the power of 16. So I'm going to factor that out. Okay. Then 2 raised to the power 4. See, if you divide this by 2 raised to the power 16, you are going to have 2 raised to the power 4, right? Then minus. If you divide 2 raised to the power 16 by 2 raised to the power 16, you get what? 1. So we are making progress. Now, what is 2 raised to the power 16? No, we can't do that yet. It's still big. Let's leave it like that first. And 2 raised to the power 4 is easy because 2 times 2 times 2 times 2, that is 16. Then minus 1. Okay, making progress. So this is 2 raised to the power 16. What is 16 minus 1? That is 15. All right. What am I going to do next? I'm going to break 16 down to 10 plus 6. It will be easier to do 2 raised to the power 10 and 2 raised to the power 6. So I'm going to write 2 raised to the power 6, or not 6 now, 10 plus 6. 10 plus 6 is what? 16. Okay, then times 15. So let's split this to what now? Still using the same rule that I used before. This 2 raised to the power of 10 plus 6 will become 2 raised to the power of 10 times 2 raised to the power of 6. If you apply that same law, you are going to get this back, okay? So this is what? Times 15. So what is 2 raised to the power of 10? That's easy. That's 1024. 1024. Times, what is 2 raised to the power of 6? That is 64. Times, this is times, by the way, not decimal point, but times. Times what? 15. See, what can I do to make it easy to multiply these numbers? Even though I can use the long multiplication method, but I also want to make it easier for me. So 1024 times 64. I'm going to rewrite 15 as 10 plus 5 because it is easier to multiply 64 by 10 and by 5 than to multiply 64 by 15. You see the logic behind this now. Okay, so this is equal to 1024. If you multiply 64 by 10, you will get what? 640. So times 640, then plus What is 64 times 5? It's easy to do, right? So 64 times 5, 5 times 4 is 20, write 0, carry 2. 5 times 6 is 30, plus 2 is 320. So we wrap this in a bracket. Now, let us proceed. So this will be equal to 1024. I'm going to add these two numbers, 640 plus 320. That's what, 960. So 960. Again, I ask you, is it easy to multiply these two numbers? Well, you might say yes, you might say no, but let's still manipulate this 960 again, because 960 is 40 less than 1000, and it's very easy to multiply any number by 1000. So instead of writing 960, I will express 960 as what now? As 1000 minus 40. So it's easy to multiply 1024 and 1000. Easy, just write 1024 and put the 3 zeros next to 1024. See what I have? So to multiply 1024 by 40 rather, I will act as if there's no zero. So I'll just do 1024 times 4. Once I'm done, I'll include that zero that I removed. So 4 times 4 here is 16, right? 6 carry 1. 4 times 2 is 8, plus 1 is 9. 4 times 0 is 0. 4 times 1 is what? 4. So I have 4096, and I will now include that 0 from 40. So can't you see that it's easy now to subtract? Let me just subtract this number. That will be what? 1024000 minus what? This is 6904. Let's subtract this. 0 minus 0 is 0. We cannot do 0 minus 4, so I'll take from here. This is 3. Put it here. This is 10. This is now 9. This is 10. 10 minus 6 is 4. 9 minus 9 is 0. 3 minus 0 is 3. 2 minus 4 cannot. We have to take one from this 10. This is now 9. And this is what? 12. 12 minus 4 is 8. And then this 9 comes down. So what do we have? We have that the solution is what? 983,040. If you enjoyed this video, kindly give this video a thumbs up and share with your friends and family. If you have not subscribed already, please do so. Let me know what you think with the way I did this. I'm going to see you in the next video. It's bye for now.